All right, so this is a video of how to solve problem A. So you have a very generous friend that agrees to give you $11 on day one. Then each day after will give you 4 more than the previous day. Your friend plans on doing this for the next 25 days. So what would the series look like? So this is a series means that we're adding up those terms. And so we start with 11. And then each day, your friend's going to give you 4 more than the previous day, which means 14 plus 19 plus ... So that's what the series would look like. And then we're going to go all the way up to the 25th day. And so we're going to generate the explicit equation that generates the numbers 11, 14, 19. This is an arithmetic sequence. And so I'm going to use the rule, our first term plus n minus 1 times our common difference, which is 4 in this case. So when I plug in 25 for n, I'm going to have 24 times 4 plus 11, and that's going to give me 107. That would be what the series looks like. So now we're going to take that, and we're going to write it in sigma notation. All right, sigma notation, again, is shorthand for this series. So I'm going to draw my sigma. I'm going to start at 1, and we're going to go all the way up to 25. And then the rule that generates these numbers is exactly what we just found with our 11 plus n minus 1 times 4. Okay, you can leave it like that, or you can clean up the inside by distributing and combining like terms. You would have 4n plus 7 in that case. Part C, I'm going to write down here. So part C now says, how much money will you have at the end of the 25th day? Meaning your friend has given you that money for 25 days. What is the total amount? So we know that the sum of an arithmetic sequence will be equal to the number of terms times the sum of the first and last terms divided by 2. So again, it's the number of terms times the average of the first and last terms. Plug that into a calculator, and you should get $1,475. Now, part D gives you a new situation. And part D says, the second friend had the same thing happen, but started with $13. And then each day after will get 2 more than the previous day. So this sequence would look like 13, the next day gets 15, then 17, and so on. But we don't know how many days this is, so I know the last term, whatever n is, would be the explicit rule. So 13 plus n minus 1 times 2. So this here is the last term. Again, we don't know what n is, but this would give it to me. So now we're going to use what we did in part C. We know the sum from n equals 1 to some other n value, to wherever we end, is equal to the number of terms times the first term, which is 13 in this case, plus the last term. We don't know what the last term is, but I'm going to plug in this equation, or this expression. Divided by 2. Again, this here is the last term. And I know this is going to equal 1,333. Now, we're just going to simplify inside here. N times 2n plus 24 over 2 equals 1,333. So this is the equation I need to solve. And so there's multiple ways we can solve this. We can make a quadratic equation. We can then factor that quadratic equation. So if I wanted to do that, I'm going to clean this up. I'm going to distribute and get it equal to 0. So when I do that, I would get n squared plus 12n minus 1,333 is equal to 0. So my task would be to factor this, or I can use the quadratic formula. N in this case would equal plus or minus, the opposite of b, plus or minus the square root, b squared minus 4ac all over 2a. And so your a is 1 in this case, your b is 12, and your c is negative 1,333. But I'm going to use the graphing calculator to do this. So what I'm going to do is I'm going to use the table feature, and I'm going to use the table feature to find what n value gives me 1,333. Notice that since this is an arithmetic series, I know n must be a whole number. And so what I'm going to do is I'm going to go to my y equals, which is the top button here, and I'm going to type in the left-hand side here, x times 2x plus 24, and then I'm going to divide that by 2. I don't need to write in the 1,333. I'm going to use the table function to determine that. So if I hit second graph, so again, second graph, that's going to generate the table, and this will give me the sum for different n values. So after 1 day, you'll have $13. After 2 days, you'll have $28, and so on. So I'm going to keep scrolling until I find 1,333, and so I just found it. My n value equals 31 days. So again, you can solve it using quadratic formula. You could factor this. So you could factor this using the diamond problem. And I believe you would get negative 31 and 43 as your two values to plug into your factors. But I think the easiest way, again, is to use the table function on the calculator.